is this? Is this working? The first thing we're gonna do is go to this, and then we're gonna go to this.
Hello everyone and welcome to another Starbase video. This video is an
And then let's see. So, I mean, there's some people that have got a bunch of scripts. But we want to know how to program, just to get a pretty good idea of what it's all about. Topics, what's this one? Alright, so let me see how this is going to work here. I guess that's kind of in there. And then for the video, we've got this. And that would be window capture 3. And then that's actually kind of a web page thing. Let's see what else. So we're looking for a script that tells us what resource scanner with stock calculations. Mining. Material scanner script. Just quickly is view the results scan performed by a material point scanner. So evidently we're using what's called a material point scanner. Now, but there's something else though. There's a sensor. Rail sensor strip. device fields. Rail sensor. There's a torpedo sensor. A laser designator. Huh. What is... there's something else though. There's another item. Devices. We might have some strange looking things appear. Pay no mind to them.
Hello, mining lasers. This is the setup you're going to need to make this work, where you basically need 2 mining lasers with a rangefinder in the middle. They
Rangefinder.
can be up, down, left, right, any orientation you want, but you will have to play around with the code a little bit to make sure that it is accurate to your setup. But I will be going over that shortly. Now let's quickly do a demonstration. First we'll just quickly look at what this does. This pretty much just makes these lasers follow you wherever you are, and they are only on if the rangefinder has a target. You can see these follow, they update every 0.2 seconds as quickly as possible, since we are only using 1 line of code. And real quick, we'll quickly demonstrate how this looks from the pilot's point of view. As you can see, these will lock on to whatever plate we put in front of them. Anyways, let's look at how this works. So for this, you're going to need to rename some fields. This is to make sure that the variable names are short. First step is to rename mining laser on to ML on both lasers. So that's its first value to ML. Second step, rename the turret bodies to RT and LT. If these turrets are the other way around, you want to make LT on the left side and RT on the right side. Or basically you want to reverse these. So this would be LT.
Some of this stuff might not be on the stream, but
they were
no worries, I can see it all.
In other words, flipped. Anyways, moving on, you also have this thing where you want to set this first field to mine. So rangefinder on stage set to mine, and this field should be set to R. That's all you need to do to set this up with the name fields, and then let's look quickly at the chip. This is the wrong one. 1 second. Here we go. It's simply this very simple line of code, where this first part sets the mining laser to on if you have a target and if mine is turned on, and the second length pretty much determines what angle it should be. Now when you're setting this up, this number right here will vary a little bit. So currently I have it set to 90 for our setup. The general rule is you take 40 or 50 times the range in meters between these two. So here we have about 2 meters of space. So it's about 100, but a little bit less, so it's 90. So we have about 1.8, and we take that times 50, and that turns out to about 90. That's just what works for this setup. So you'll have to play around with this number. If you're overshooting or undershooting the angle, just change this 90 value to a value that works for your setup. That's the one you're going to be changing. Otherwise, this should work for all intended purposes. This 20 is whatever you have set your maximum rangefinder to. We can technically turn this up to like 24 if you want to, since these mining lasers are a little bit closer. We'll stick to 22 just to be safe, and that will basically determine the range of your mining lasers. Remember, the maximum range of mining lasers is 20, so depending on how it's set up, you don't want to...
Hello. The conclusion is that there should also be projectiles like that. And there are. So let's different versions of each part, and they are in. Then there's the fuel tank. A variant of it explodes upon contact for the missiles to be further modified and programmed using the universal tool and Yolol. Be ready to be launched. Each of these parts has their own device fields as well. These device fields allow for the missiles to be further modified and programmed using the universal tool and Yolol. When the detonate field is changed to 1, the missile will explode. Then there's a safety value. When it's set to 1, the fuse can't trigger the warhead to detonate. There's also settings for a timer that you can turn on in order to make the missile detonate after a set number of seconds. The trigger range field is used to have the missile detonate when an object is within a specific distance of meters. In addition, the fuel tank has device fields for the amount of fuel in it, and the thruster has 2 fields. The current thrust field will always display the current thrust of it, and the target thrust field is used to set the speed for the thruster to attempt to achieve. You can launch the missiles directly with your universal tool, but in order to easily launch multiple missiles, you can use the missile launcher. The missile launcher is a mountable device that holds 9 missiles at a time and works as the link between the missiles and the device network. You can use the missile tool, but in order to achieve. You can launch the missiles directly with your universal tool, but in order to easily launch multiple missiles, you can use missiles at once, or one that launches them.
Well, this one is 6 minutes long.
Introduction to the world of Yolol. Yolol is Starbase's very own programming language, which is at the core of what enables Starbase's creativity. Yolol is what is used to control and manage the vast variety of Starbase's different devices, such as doors, lamps, elevators, rail movers, tractor beams, even spaceships and factories, and anything else you can imagine. So, wanna know how to make your ship fly on autopilot? Or program your battleship to have a controlled aiming system? Have robot arms do your bolting for you? Or maybe build your own manufacturing line for ship parts? Well, after watching this video, you'll know how to get started with all that and more, as they are all achieved with the use of Yolol. Yolol code is written and executed on Yolol chips, which are movable containers for Yolol scripts. In order for your Yolol script to work, the chip needs to be placed in a chip socket, which is used to connect it to the device you wish to control, as well as a power source. A chip that is connected to a device has access to all the devices in the same network. The chip has multiple lines that you can write your script on, and when you press play, it starts reading the lines in a loop from top to bottom, spending 0.2 seconds per line. The green flashing text indicates which line it's currently executing.
So you use colons in front of a variable, and you set variables with a 1 equal sign. If you're using if-then statements and you want to have something set equal to some certain number or variable, you use 2 equal signs. And that's in the... That's on the web page that talks about the variables. You could probably see some of those. Those are for variables not using the if-then statements. Logical operators is what they're talking about, where that's used. I guess something with an exclamation point is a string, meaning a text, a set of text or something. So this is a string where it's using part of the text plus a number, or you could even put a variable in there. I tried to do some basic programming in one of my earlier streams, didn't work out very well. That's okay. There's memory chips, data networks. I want to look at this memory chip. Non-functional device uses to share data between two Yolol chips. This uses Exorium. Chip field. Anyhow, where's that video?
As for how to get started with writing a Yolol script, here are the basics. First of all, you need your universal tool. The universal tool is a forearm mounted screen, and it can be used to view detailed information on data networks, devices, cable networks, Yolol chips, and more. It can also be used to write Yolol script by connecting it to a Yolol chip. Here we are going to use it to check and change the IDs and values of different devices. The IDs are properties that are used for controlling devices and connecting them to each other.
Those are actually variables.
You will use these IDs when you write your script. Here's an example of a normal buttons info. First, there's button state, which represents the current state of the button. In this case, it's 0 when the button is not pressed and 1 when the button is pressed. Then there are button on state value and button off state value, which control the two values of the button that change when it's pressed. For simple buttons that open doors and such, these are usually 1 and 0. Finally, there's button style, which controls the interaction style of the button. 0 stands for a hold down and release button, 1 for a basic click to toggle button, like this one, and 2 for a 4-stage switch, like a click pen. These names and values can be freely edited at any time, and some devices have more IDs that can be controlled than others. You won't have to worry about remembering what each ID means, as more detailed info on each device's specific IDs can be found in-game, as well as on Starbase's own wiki. Now here's a simple example of automation that can be done with Yolol. We'll use it to program this door to open and close on its own. First, we're going to open our universal tool to check the door's IDs. The important ID to note here is the open state ID. When the door is closed, the value is 0, and when it's open, the value is 1. Now we're going to open the Yolol chip and type the ID on the first line along with the colon prefix, which is needed before external variables such as IDs. Then we're going to type an equal sign and a 1. This assigns the value of 1 to the variable open state and makes the door open when this line is executed. Now we'll write the same thing on another line with the exception of changing the value to 0. This makes the door close when this line is executed. Since it takes 0.2 seconds for the chip to process each line, the lower we'll write this piece of script on, the longer it takes for the door to close.
1 second.
And simple as that, the script will already work like this, but in order to make it more smooth, we can use the goto command, which will make the chip skip the extra lines that aren't needed. Now we'll just press the play button to commence the script, and as you can see, the door opens and closes every time it reaches the respective commands on the Yolol chip.
That's
Here
weird.
are
It
examples
doesn't
of
go all
some
the way
basic
down.
operators you can use. Greater than, less than, greater than or equal to, less than or equal to, not equal to, and equal to. These operators return a 1 if the statement is true and a 0 if it's not. They are often used, for example, in if statements. An if statement checks if a condition is true and runs the script based on the result. Usually they look something like this. If something is true, then do something, else do something, end. In addition, you can use the not, and or keywords to set up more complicated conditions than simple variable value checks. There are different tiers of Yolol chips, and the available operators are limited by the type you have.
Oh,
The
really?
basic chips have a limited selection of functions, while more advanced ones can perform more complex operations, like trigonometry.
Oh.
Another thing that helps with more complex Yolol scripts are the modular device racks. They allow for mounting Yolol chips in a more compact manner, as they can store multiple chips inside them. This makes them very useful for multi-chip Yolol systems. In addition, a core part of any multi-chip system are the memory chips. They can store message IDs for data sharing between multiple Yolol chips and can be used as a physically transportable data storage medium. Now there's still more to learn, but these are the basics that will help you get started with Yolol when the time comes. As an extra treat, here are a few more examples of Yolol in use. It can be used for automated public transport, to make your own in-game games, or almost any kind of contraptions that you can imagine. These are only some of the things that our development team has thought of, but as you can see, the possibilities with Yolol are endless. If you're interested in a more detailed overview on Yolol, check Starbase's own wiki. And while you're at it, don't forget to visit our official Discord, where we are actively answering questions and sharing Starbase clips and images.
Okay. Well, let's go back and look at the web pages, because we're looking for a specific script, and it may help to find that a lot quicker if we just look for it. Material point scanner. Oh, you know what? So you could add... See, this is just the hardware. So you mount this on a turntable. I wonder if it's possible to add 2 items. See, we've got to have these materials. Arcanium, Cutarium, those are the tough ones. Agesium. It doesn't take that much. Plutonium, Arcanium. Let's see. Oh, crap. So we go look for ores. Now you see one arcanium is 16,000. That's quite a lot. The cutanium is 17. And the agesium is 5. Those are like the most expensive ones. So I'll be doing some mining near the outpost probably and bring stuff back because it's the only place you can get credits. Or actually you could buy, what if I bought there's a rangefinder, there's plenty of those, that's cheap. Oh my god. It's just 1,000 for the material point scanner. Oh, it's just a no-brainer. Why spend all that other money for the ore when you can just get one of these? You know? We'll grab ourselves one. And there it is. We only need one. So we can just plug that into a mount. That solved that problem. So there's a rangefinder. There's some other stuff. So laser designator. I mean, this stuff is so easy to buy. Why build anything? It's like you just get the credits and buy shit. I haven't really figured that out. Why should I spend 35,000 credits to build something when I've got it, when I just buy the part? That was easy. It doesn't say what the range is. So let's see if we can look that up. Material scanner casts array 100 meters long.
going to assume that you know how to build the ore detector and the basic infrastructure around it. The main thing you need to know is that the ore detector, or material point scanner, goes into a utility body, the large one that needs a weapon mount too. In addition to the material scanner, we're also going to need a text panel and a button. Text panel, set it to scan. Next we're going to call the button sense. And then we're going to set up the point scanner as well. We're going to call it active, the same as our button. So, sense, we'll call index IDX. Scan results, we're going to abbreviate this as well to RSLT, material to mat. Next and last, we move on to the program itself. It's only 2 lines long. The first part just sets up some variables such as a new line character, an iterator for the loop that'll be in the next line. We reset scan, which is the text panel. And then we check to see if the scanner is on, the material scanner, by a little if statement. So if sense, that's the button and the activate field for the ore detector, material scanner. So if it is less than 1, so off, then we're going to set our text panel to say off. And then go back to this line. And if it is on, it'll just skip over all of this statement within the then, and we're going to go on to the next line. Here, we have a giant loop that iterates through all of the results. So if we haven't looked at all the results, then we're going to set our index. Index is the material point scanner, which material it is going to show you at this time. We're going to set that to our iterator. Then we're going to add the currently shown material at that index plus the new line character, so that the next material added will be on a new line. Lastly, we're going to add one to our iterator. Go back to this line to check if there's any more results.
I just fell asleep to that.
Otherwise, we're going to go back to the first line. Let's see if it works. Turn it on. Sometimes it'll show weird values, so we're going to point at this asteroid, Agitite, and Bastium, and it'll just keep cycling those. Thank you very much for watching. I hope that you were able to learn something, and again, the script for the material detector is down in the description, so please use that at your leisure. No need to credit me unless you feel like it.
Xeno Cow. I recognize name. Let me just go ahead and drop this for a second here. So on my desktop I have a gaming and Twitch. That was pretty cool. Nice and simple. I'm just going to go ahead and copy that code. And I will also copy active to active sense, index to index, scan results. Actually, he's got the whole information right here. That's pretty cool. Um, so the material point scanner is 100 meters. I think the laser is 20 meters. There's a laser designator item, which I don't know exactly what that is yet. It's a rangefinder. It goes out to 1 kilometer. Rangefinder distance will show the value set in rangefinder search length if the beam doesn't hit anything. That would be a rangefinder. Create balance systems for spaceships by comparing ranges on the opposite sides of the ship. Hover ship elevation controlled by comparing elevation level to a rangefinder. Let's look at the torpedo thing. Laser sensor. Cloaked stealth ships. This is Starbase Infinity. Huh. guided via a laser designator. Maximum length of the beam measured in meters is 1,000 meters. The rangefinder is 1,000 meters. Whether the rangefinder should try to be on, 0 is off, everything else is on. Measures. The output field reports the distance the laser goes. Measures in meters. What torpedo laser sensors connect to? Ident field. See, this reports a distance. That also... Wait, that doesn't... I wonder how much those laser designators are, if there is one. Well, they got plenty of those. That's not too much either, is it? So what did I get? I didn't get a laser designator. I get the material point scanner. So the material point scanner only goes out to 100 meters. So if I want to set up on a turret to scan, and when something is found, well, that takes too long though. So if I had it mounted on a turret with a chair, and I'm inside of a ship that's protected with a canopy so I don't float around, that'd be cool. And then I could actually fly the, well, oh my god, what if I put the whole pilot seat on a freaking movable chair? You know? That'd be cool. We'd have to get some of this other shit to do that with. See, I think ahead. So that's like not too expensive. You got turret turbo, that, and all that other stuff. You can buy this crap, you know? Look at the mining laser. That's what's expensive. You could get some of this other stuff and just play around with it, you know? When we get to the Yolol, which I haven't got to yet. We're supposed to do programming. Well, we're thinking of mining, scanning, you know, all that good crap. If you don't want the volume of the materials, you can just take out that. That's this other guy's script here. I think. See, I have to drop this to check something. So he's got, go to 1 cents, $1. That's supposed to be cents is less than 1. And that's a key that I don't have on my computer because it's broke. But I've got it here. So that's supposed to be a less than. If iterization, why has he got a $sign? Jesus. That was fucking loud. Fuckers don't know how to fly. Alright, there's another one here. Holy God. If you crash like that, well, we're not. Scan equals volume plus n go to 2. If you add this in the third line, change your volume to vol. It will show the aura amounts. Here is my script. So he puts it in a picture. If scanner's X1 goes to checker equals 0, string material, string volume. If checkers less scans, go to 9, index equals checker, string material equals that plus n, volume is that plus n, checker, go to A, and a loop scanner. I don't know what that is. Now let me save this. Bring this back up. Where's the code? So here's one. Full automatic asteroid classification. Alright, see, I'm gonna have to drop this for a moment again. I don't want to take a chance on my stuff to come up here. Default name, new name, default value, default name. basic Yolol chip. Text panel. So I'm copying some stuff from this GitHub thing here. Text panel, new name, panel. What? It's the same thing. Panel variable resolution. Button. Sorry that you're not seeing anything, but I am sort of explaining a few things. New name. Button style. New name. Okay, and then the code. Copy. Okay, that's in universe code, whatever that is. God, I don't know what those fucking figures are. In SSC. I have no idea, you know. Let's just pop this back up here again. Collaborative Yellow Learning Open Network. Cosine basic chip. Ooh. Calculates the cosine of I and puts the result into... Oh, that's on a basic chip, huh? What I will do is I will copy that. Let's see, I didn't want to do that, damn it. It shouldn't show up on my thing. I'll just put a link here because it's getting late. And I will get into, there's ISAN, fuel calculation time, material scanner, resource count, square root basic chip. So we're looking at material scanner. You do not need to change the default names. Okay, so I can probably copy this. Include. This is a little bit more, oh, you know, maybe you can't use that code. Well, include standard logic. That must be for the professional. Material scanner, is that back up? Minus suffix 1 minus suffix 2 minus suffix 3. Material out equals mat plus colon plus material scanner volume. Mat scanner index. Huh. This is a do while. Huh. So I'm not really, that's, none of that's over my head, but the idea of what's happening, let's see what this readme's all about. I did that. So there's a thing there. 29 repositories. Repositories, I can't even speak. Development kit. Yolol. A Visual Studio Code extension that makes the features of CLI available directly in VS Code. A new programming language called Yolol that extends Yolol with a lot of features. Experience developed really miss when using Yolol. Learn more about Yolol. CLI, compile Yolol code to Yolol. Start a language server, protocol server. Yeah, that's probably not going to happen. We don't need to learn. Yeah, that's not going to happen. You don't need to go that far. That's crazy. Iodine. Visible button name. LUA. What is LUA? That's a direct. What? Huh, they've actually wrote some code that they're programming into the game itself to change things. Yeah, that's not gonna happen. A vector-based language that transpiles to Yolol. Oh, brother, what are they doing? Not a clue. That's a C source project. This is all in C# or something. I'm not sure what they're doing here. A Yolol-based GPS for the game Starbase Enigma Machine Simulator. He wrote this in a Python script. Formatting main reflector reset wheel. Write a message in message and start. Log will show output message. Not sure what that's all about. Position and velocity readings using a single receiver. Multilateration script using 4 transmitters from the starter cluster. Hmm. Well, let's see. That's a GPS code of some sort. Use a single receiver. Four transmitters from the starter cluster. They don't have transmitters working though. Hmm. "12 months ago." Maybe I should make a note of that. Oh, they're using. I see the transmitters. They're using the locations of the Imperial, and that's what I've been trying to look for actually. The Imperial Station, the Kingdom Station, the Capital Imperial, and the Station Proving Grounds. Those are the 4 transmitters. They said those weren't working though. Okay, so much for that. So there's some stuff here. Mining laser sweeps. Bruh. Actually have an idea for something that I want to do. So I'm pretty much just looking at this code so that I can understand the programming aspect of what they're doing. Flight time, instant generator. I think what I'm going to do is just copy these links and look at them later. Wherever the heck I did with the links. Now this is... I don't know what they're doing here. This is like, not really a clue, you know. Nav list? What's this? For the core script, add and one additional each one for extension added. Each chip can hold a maximum of 18 destinations. XYZ coordinate. Nav list. That looks pretty cool. That's when we ever get into the ISAN and all that other good shit stuff. Proportional integral derivative library to help create PID code. Controller generator with a PID. Generator automation. I don't know exactly what all that is. What the heck is a PID? Meh. Not a clue. Cargo lock stuff. I'll just grab that link. Looks like we're pretty much almost done here. I probably won't be getting to actually put any code in. I don't know what that is. Yolol simulator. Parsing Yolol script of all Yolol chips across the network. Free to use and sell. You're not supposed to sell other people's work. It's copyright. I wouldn't do that. Panic. Yeah, let's panic. I'm good with that. Well, there's a bunch of links. I mean, there's different scanner files. This one is as a PDF. Oh, shut up.
Buddy and welcome, this is Spoonie with another shipbuilding tutorial for Starbase.
It sounded
Pasting
like
directly from the PDF provided by Collective, who again are the
sounded like you
to
said
one another, but they don't
shipbuilding.
need to be right next to each other. Make sure you add cables to those, and then we're going to go back to our asset browser, and we're going to add small turret. So select one of your small receivers, and it's important to notice that when you select it, there are two options here. The small navigation receiver, as well as the turret base. We're not going to change anything on the turret base, so just click over to the small navigation receiver, and we'll change the listening angle first from the default of 45 to 180. And this is why it's important to have the small turret turntable. Without the turntable, this can't go beyond 45, and your ISAN will not function. Next, we're going to change the signal strength to just the letter A, and the target message to just AT. We're going to do the exact same thing for all four of our receivers, except our second one we will name B and BT, C and CT, and our last we'll name D and DT. Double check that you've named everything correctly, and then we're ready to move on. So before we get into Yolol, we're going to set up a text panel. Make sure you bolt this down. And then we're going to change the panel value name to just an underscore, one single underscore. And now that's set up and ready. We can get into Yolol. So for this you can use a basic Yolol chip, but if you want to use the speedometer function, you need to make sure you're using an advanced Yolol chip. So in our asset browser, we're going to pull up a chip socket and an advanced Yolol chip. Make sure it's bolted down and make sure you've added cables to your socket. For this next part, we're literally just going to copy and paste the lines directly from the PDF into our Yolol script editor. Instead of including this Yolol script in the description or linking it in the comments, because this is not my own work, I'm instead going to link to the PDF of Collective who did write this.
So this is what's called ISAN. It's
Now that we've copied and pasted
XYZ
all of the Yolol lines, we need to change the code in
navigation
one way in
program
order
that
to
these
use the
guys wrote.
speedometer.
It's very
If you're
long and
not planning to use
complicated.
the speedometer, you can skip this step, but if you do want to use it, you need to change on the first line the SP equals 0 to SP equals 1. That's the only change you'll need to make. Now that that's all set up, we can jump into test mode and see how this works. On the text panel, you can see our X, Y, and Z coordinates begin to propagate. And sometimes when you first start ISAN, the speed value, or the S, on your text panel will sometimes show a number that isn't 0. That doesn't mean it's not working, it just means that it needs a moment to boot up. If you'd like to restart ISAN, or you're having problems, or you're streaming and you don't want somebody to stream snipe you, you can just bring up your universal tool, and in this value field, you can just select the entire line by pressing Ctrl A and delete it. Then just press enter, and what this will do is turn ISAN offline. You can see on the text panel it now reads ISAN offline. To boot it back up, all you do is the exact same process a second time, and it will reboot. Now we'll test out the speedometer and make sure that's working as well. As you can see, as we begin to move, the value S, which is our speed, at the bottom of our text panel begins to increase. And that's everything you need. In a few minutes, you can have ISAN up and running on any ship. If you'd like to add ISAN to a ship that you already have that's not in the editor, you can buy any of these components on the auction house. They're not particularly expensive.
Yeah.
I'd like to again thank Collective for their incredible...
Yes, Collective. Asteroid Avoidance. I don't know why the volume is so extremely loud.
Hey and welcome, this is Spoonie with another shipbuilding tutorial for Starbase. In this video, I'm going to show you how to make an asteroid avoidance system. That way your ship will
Look at
automatically
all
move
the
its way out of
rangefinders.
oncoming asteroids, which is really important when you're outside of the safe zone, because those asteroids can hit your ship and they'll do a lot of damage. This is a really easy system to set up. It only has 5 lines of Yolol, and the ship in front of you is rather large, but you could accomplish the same thing with as few as 4 rangefinders. First, I'll demonstrate how this works, and then I'll show you how to build it. So we're going to start by activating our asteroid avoidance system. You can see these green beams, which project 1,000 meters out, and if anything comes into contact with one, the ship will react. I'll break one of these beams on the left side, and the ship will move to the right to avoid me. If I break one of the beams on top, the ship will move down to avoid me in that direction.
That is cool. Look at them triangle thrusters. Ain't that pretty,
This
huh?
doesn't require you to slow down in order to work. You can be moving at full thrust, and your ship will still automatically move side to side or up and down in order to avoid any oncoming asteroids. This can keep you from having costly repairs or keep you from becoming stranded outside of the safe zone and losing your ship entirely. So we'll set this up on this much smaller ship that we constructed in the first series of tutorials. The only things you'll need for this are a Yolol chip, a button, 2 centering levers, and some rangefinders. I'm only going to use 4 rangefinders to set this up.
God,
for
look
left,
at all the
right,
freaking
up, or down.
cargo blocks
But you can
he's
use as
got,
many
and
as
he's
you
only
want.
got
It doesn't
4
increase the
box
difficulty.
thrusters.
The process is exactly the same, and it doesn't increase the number of lines in Yolol you'll need.
How the
You'll
hell did they
still
get
only need
away with
5.
that?
So first we're going to set up a control table stand and a control table so that we have somewhere to put our levers.
That's a
If you already
12-minute
have levers
video.
set up for up, down, left, and right, then you can skip this step. So in the asset browser, we're going to search for control, and we're going to use the control table stand. And then a control table plate.
Okay, that's some new stuff I'm learning.
Next, we're going to place 2 centering levers. And then we'll need a Yolol chip. So first we'll need a socket. And then just a basic Yolol chip will work fine. Don't forget to bolt everything down.
Nah, just leave it floating. Don't listen to him.
And don't forget to add cables to everything. The next step is to name these levers. Again, if you already have left and right or up and down levers set up, you don't need to do this again. But in case you don't, we'll change the lever state field to FCU right, left, with no spaces.
That
next
information is on the
We'll change to FCU
flight computer unit.
down, again with no spaces. And if you forget, you can find these values on your flight control unit. And next, we can move on to adding our rangefinders. For that, you'll just need a hardpoint and a rangefinder.
Look at all the cargo frickin' boxes with just 4 thrusters on here. What the hell?
We're just going to copy and paste these.
How could that ship be?
And I'm going to place
Oh, you know why? 'Cause he's got no plates.
one on the left and the right.
There's no plates on that design.
And then one on top and bottom.
Huh. Seriously?
Remember to bolt these down. And then we'll need to rename them. So select any of your rangefinders, and we're going to rename the top and bottom fields. Where it says rangefinder state on, we're going to change this to just AAS for Asteroid Avoidance System. Do this for all 4. Next, for any of the rangefinders that you have that will be on the left side, you're going to change the rangefinder distance. The name value will change to AASL.
I was wondering about that.
On the right, we'll do the same, but we'll name it AASR. We'll name the top AAST, and the bottoms AASB. The last change we'll need to make to the rangefinders is to change the default rangefinder search length. By default, it's set to 5, which is a pretty short distance, so we're going to move it all the way up to its maximum value of 1,000. Again, do this for all of your rangefinders. Don't forget to add cables to the back of all of your rangefinders, and now we're going to set up a button so that we can turn our system on or off. We're going to use a hybrid button, but you can use any button for this. Don't forget to bolt these down. And we're going to change the button's state name value to just AAS. We're going to change the button style from a 0 to a 1. If this is set to 0, you'll have to hold the button down. Now that we've got our rangefinders, our button, and our levers set up, we can get to the Yolol. So on the first line of Yolol, we're going to set up an if statement that allows us to turn our system on or off using the button that we set up. To do that, we're going to use an if statement that just says if the value of AAS, so colon AAS, don't forget the colon, and then we'll use 2 equal signs to tell it to look and see if this is true. So if it is true that the value of AAS is 1, then go to 2. Else, go to 1. And remember to put end at the end of all of your if statements. So what this statement will say is to check and see if it's true that the value of AAS is 1, and if it is, go to the second line. Otherwise, go to 1, which is the line we're on, so it will just continue to read this line until it's true that the value of AAS is 1. Next, on the second line, we want to tell Yolol that if something breaks our top beam, to move the ship down and out of the way. To do this, we're going to use another if statement that says if the value of AAST, which is what we named the current range on our top rangefinder, is less than 1,000, then the value of FCU up down equals -50. End. This number can range between 0 and 100, either positive or negative.
That's
if it is
only
positive, it will move the ship up.
0.2
If it is negative,
seconds.
it will move the ship down. 100 would mean that it is full thrust.
Yeah, but it's...
So we're going to start with 50 because full thrust is probably not necessary, but if you had a larger, heavier ship, you may need to set this accordingly. Now, we'll test this line of code before we move on. To do that, on line 3, we're just going to write go to 1 so that it repeats these lines and doesn't waste a lot of our time. But let's enter test mode and see if this works. First, we'll turn on our system, and we'll break this top beam and see if it moves down and out of the way. As you can see, as soon as that beam is broken, the ship thrusted itself down and out of the way. Next, on the third line, we're going to do the same thing, but for the bottom beam.
Oh, I
So
see.
on
Left
line
and
3,
right
we're going to
is
delete the
pointing
go to 1 that we wrote, and we're going to use the same if statement.
on the
If,
front.
only
Okay.
this time we'll use the value of
What are the side
AASB
ones for?
For bottom is less than 1,000, then FCU up down equals 50. End. On the fourth line, we'll do the same thing, but this time for the left side. So if the value of AASL is less than 1,000, then FCU right left equals negative 50. End. And on the fifth and final line of code, we'll write if the value of AASR, which was our right side,
You're traveling
less than
150
1,000,
meters per
FCU
second.
right
You've
left
gone at least 100
equals
meters
50.
before this program even has had a
We will
chance to
include
react.
go to 1 on the sixth line, which will just keep this repeating itself instead of reading all of these empty lines of code and wasting time.
So if you've
Now
got
let's enter test mode and see if it works.
1,000 meters minus 100 meters, you're at 900 meters for that thing to change in 1 second.
Ideally, you'll want enough beams that it covers the edges as well as the center of your ship to avoid getting hit head-on or clipped by any asteroids, but this demonstrates how it functions. As you can see, the ship is successfully avoiding me whenever I break any of these beams. So for larger ships with multiple rangefinders, the setup is exactly the same, and the Yolol script is exactly the same. All of these left-sided beams share the same name values. They don't need to be individually named. As you can see, the current range on each one of them is named AASL. If any of these drop below 1,000, the ship will move out of the way.
Can I go to sleep while my ship is flying? Is that the end? Yeah. Well, that's okay. Yellow script left. I guess that's it. What? Oh, the $sign is less than. So this is an avoidance script. I guess that takes care of that. And there's some other stuff in there. Laser designator. And there's... So we went over all this stuff, didn't we? The one thing I didn't really go over is the programming, I guess. But we'll just have to do that a different day, because My mining ship. Wait, let me think. So I go here. Milo's 2. I should probably go into my dark and light game tonight before I freaking crash. So this guy built this thing without panels. Oh, this is my my mining ship that actually goes like a bat out of hell. Except for it goes northwards. I tried to put more of this stuff on here. Maybe I could put more on here. Let's see. Yeah, I don't know how that guy did that. I don't know how to deselect yet. So this is the what happened here? Is that because of these guys being added? What the fuck happened here? Maybe they're not welded? What the fuck is going on? My weld function is not. Hmm. That frame section is not. I had this working. Fuck. Why the fuck is it not strong enough? Oh, I see why. Maybe I flew this in the red anyway. Yeah, let's just test it. I like to watch the flames come out of it. Oh, it's actually going a little better. Yeah, creak it. Just creak it, you know? This is not the ship that I want. Let's see. This is probably my other main ship, which is in parts. And it's got some stuff on here. So there's a laser designator, huh? Let's go in there. Oh, that's little. Well, I don't feel like adding another. That's a thruster. Fuck. Shit. See, that's a device hard point. I played with two different things. No, I think, is it this one? This is... How the hell do you mount this? That's a tool body. Fuck, what is this? Fixed weapon mount. Uh-oh. Where the fuck is that now? that could be it. So the long side is on the left. And then supposedly how the hell am I gonna put that in there? Fuck. Jesus, how the fuck is it going here? I can't get this mounted in there. This doesn't go in there, does it? It doesn't fit in there. I don't know how to do this. Not a clue. Did that just... Oh my god, what is this? Fuck. I don't think I got the time or the patience for this tonight. I wanted to read them damn values on that fucking laser designator, but it won't let me. Oh, it does actually. Identify field. See, I'm thinking I can use this somehow. Well, that's a lot of mixing and matching and shit to do, you know? Trial and error to figure this out. I gotta call it quits. I just gotta call it quits. But that's cheap, that's cheap. The rangefinder's cheap. The turntable mounts, all that stuff is cheap. You know what? Fuck it. I want to try something. There's something else that I wanted to try that I'm gathering. I don't know why I'm getting this error down there now. I gotta get into that dark and light and deal with that. Fuck. So my question is... Pilot chair stand. Can I put that on a turntable? Is that... Shit. Says this guy, a turret cradle. Huh. A turret turntable. Just... Oh, they got weapon side armor. That's cool. It doesn't fit on there. Oh, yes it does. Ooh. No, that's what we're talking about. Turret cradle armor. Turret cradle advanced. How do I get that closer? Oh, did it fit in there? It fit in this one. That's the, what? Turret body? That's not a turret body, that's... It fits in there too. That's not right. That locked into something. What did that log into? What? The hell? Is that even... That's not even connected. There it goes. So you've got to have... Let's see. Shit. So this has value, turret pitch, current turret, max rotation. What? Turret cradle. Huh. Talus miner. So does this turn? This does not turn on its own. You've got to have levers to control this thing, huh? And of course I can't read anything because there's no data connected to it. Let her rip. Ah, get me out of there. Damn it, get me the fuck out of there. There we go. I like to see that fucker take off. Anyway, there's a bunch of stuff to do, a bunch of stuff to work on. I'm thinking about putting this in as the pilot chair because if I now let's say the ship is just flying straight and I'm using this to locate the asteroids instead of you know what I mean? Instead of the or like if I had this on the front I could have this locate the asteroid as I'm flying through space. It reaches out to 1,000 meters. You know? But I gotta call it quits. Lots of ideas. Definitely, I played beyond my scope today. That's what I did, and this is all freaked up. Oh, I gotta go on that other freaking game. Just do that real quick so I don't lose my freaking houses. All that kind of good crap, you know?